to today's webinar titled Inspection Authorized Refresher Training, A to Z. I'm Gary Mitchum, the Airworthiness Fast Team Program Manager at San Antonio. And I produced this webinar as an aid for IAs to meet their refresher renewal requirement. Now, the regulations that I put on this presentation are just paraphrased for brevity. So if you ever have a question about a regulation, please look up the entire regulation. So this presentation provides information to A&P mechanics and inspection authorized A&Ps. Our objectives today are to ensure maintenance personnel know where to find information, ensure that only airworthy aircraft are approved for return to service, increase mechanics' knowledge of aircraft maintenance requirements and programs, and increase aviation safety to prevent accidents. Safer skies through education, which is the FAST Team motto. Part one, we're going to look at the resources available to you, some regulations and definitions and tips about reading the regulations, performance and inspection rules, privileges and limitations, IA initial and renewal criteria, understanding airworthiness. We're going to look at a ferry permit case study, factors influencing airworthiness, and then the life cycle of an aircraft. In part two, we'll look at maintenance records, overhaul versus rebuild, falsification, parts approved, unapproved, and life limited. Going to look at a parts case study. And there's a portion called Understanding Airworthiness Directives with 3 accident studies, inspection requirements, inoperative equipment, which is regulated by Part 91-213. And then briefly, we're going to look at major repairs and alterations. So resources available to you. Best place to start is FAA.gov. And across the top of the page, you'll see the tabs. Those are the main tabs that you're going to want to use. They consist, there's 8 of them: aircraft, air traffic, airports, pilots and airmen, data and research, regulations, space, and drones. At the bottom is the site map. So if you ever get lost, just look at the bottom of the page and you can find your way. Now, if you go back to the top, the 2 main tabs that you'll look at as mechanics are the pilots and airmen and the regulations tabs. If you click pilots and airmen, the drop-down mechanics tab is probably the most useful to you. When you get to the mechanics landing page, you'll see all the hyperlinks that are available. Advisory circulars, ADs, type certificate data sheets. You can see even TSOs. All the forms are there that you'll need. If you dig a little deeper and look at advisory circulars, you can search by number or browse by the topic. And here's an example of AC 43.13-1B, acceptable methods, techniques, and practices for inspection and repair. And now this is actually approved methods for Part 23 aircraft. Here's another one on corrosion control. This might be a good screen to take a picture of. I just went through and tried to find the main advisory circulars for mechanics. And this certainly is not a complete list, but if you're ever wondering if there's an AC for a particular topic, this might help you. I'm not going to spend a lot of time on AD search right now, but because we're going to look at that later, but you can search for ADs. And there's the search window on the left. Type certificate data sheets. And there's the menu for type certificate data sheets. You can look it up by the aircraft make or the actual type certificate data sheet number, so on and so forth. Here's a really old one. Some of these pictures come from the National Archives, World War II era. In the mechanic forms section, here's some of the forms that you most commonly use. There's your suspected unapproved parts report, 337. And you can also search the forms database. There's 337. And there's an application for IA. Under the regulations tab, excuse me, if you click FAA regulations, it'll bring you to this window, and then you want to pick current federal aviation regulations. Takes you to the electronic code of federal regulations page, and the ones that are most pertinent for our purposes are part 1 through 199. And if you type in the search window where it says go to CFR reference, if you put in 14 CFR and then like 91 or 43, it will take you directly to that part. And then there's a table of contents that's very handy for looking up what you want. Also under the regulations tab, two really important ones are handbooks and manuals and orders and notices. Under the handbooks and manuals, you're going to want to click Aviation Handbooks and Manuals. And these are probably the ones that I would actually download onto my computer. I don't think I would print them because they're 600 pages, roughly, full of really good information. They're in color now, lots of good pictures and figures. But you've got the Aviation Maintenance Technician Handbook, the General. You've got the Airframe Volume 1 and Volume 2. And you have Power Plant Volume 1 and Volume 2. There's a front cover sheet of the General. It also has the Plane Sense magazine in there. And if you go under the Regulations tab and pick Orders and Notices, you'll come to this page. And if you pick Examiners and Inspectors, you can actually find the orders that FAA inspectors use to do their job. It's Order 8900.1. And if you click on that, there's quite a few different volumes. But here's an example of a ramp inspection. So you'll know all the secrets of an FAA inspector, how we do our job. how we conduct surveillance and what we're supposed to look for. This is the order we have to follow. They are written very well. Service bulletins and manuals are not on the FAA website. You have to go to the manufacturers for those. Most of the manufacturers provide the service bulletins free of charge. You might have to create an account. And don't forget the manufacturer websites. Today's internet, it's very easy for the manufacturers to distribute information. Okay, somebody said they're not getting audio in the question and answer. I'm assuming everybody else has audio. Okay. Yeah, I'm not sure how to help you. It must be something with your computer. So here's an example of the Tempest spark plug and Champion spark plug manuals. So to summarize our section on resources, just remember FAA.gov. Across the top, there's the tabs. And the two most important ones for us are pilots and airmen and regulations. And under the pilots and airmen, the mechanics landing page has those items. And the regulations tab is where you'll find handbooks and manuals, orders and notices, and you can find the FAA inspectors' orders and guidance. All right, this section is about regulations. Here's a chart of the aviation safety regulations, Title 49, transportation at the top. The primary regulations that affect you as a certificated mechanic or repairman are in volume 1 and 2, and these include part 43 and 91. And if you are working on a part 121 or a 135, 10 or more aircraft, you are actually part of their maintenance department, even if you are not employed by them, and you must follow their manual and inspection program. And here's just a big list of the regulations that are most relative to our work. And the list goes on. Next, we're going to be looking at some tips when you're reading the regulations. Always read the applicability statement first, because you can waste a lot of time and find out that it doesn't even apply to the aircraft that you're working on. Here's an example. The Part 91.401 applicability statement. Notice that it says 91.411, which, as you all know, is the altimeter, altitude reporting, and leak check regulation, doesn't even apply to aircraft that are operated under Part 121, 129, the 91 fractionals, or 135, 10 or more. And how many times have I seen log entries in these in these aircraft operated under these parts that say, that are signing off 91-411, when it doesn't even apply to these airplanes. These aircraft have to be maintained under their inspection program. So the correct sign off for the altimeter, and most of them are RVSM, would be in accordance with the operator's inspection program, which is usually based on the manufacturer's maintenance manual. Also, be aware of mandatory language that is enforceable, shall or must, prohibitive language, like no person may, or a person may not, or shall not, conditional, except or unless. Those are the ones that make our regulations get pretty confusing, or my favorite, notwithstanding. That's also another one that kind of gets you really thinking and scratching your head. Person, if you see that, it means everyone, including you. Aircraft versus airplane versus rotorcraft. Some regulations apply to rotorcraft, some apply to airplanes, some apply to aircraft, which includes both airplanes and rotorcraft. And authorizations are enforceable if you violate your authorizations or privileges. And just to reiterate, when you see person, that's the definition of person. And it's basically everyone. You see a lot of regulations that say no person may, so that means that covers everybody. Definition of maintenance. Definitions are in 14 CFR 1.1. Maintenance, it does include inspection, repair, overhaul, preservation, replacing parts, but notice it excludes preventative maintenance. There's a difference between maintenance and preventative maintenance as far as regulations are concerned. Article, the word article is often used when discussing parts. Appliance is a very important one for IAs. It's any instrument, mechanism, equipment, part, apparatus, accessory that is installed in or attached to the aircraft, but it's not part of an airframe, engine, or propeller. Some examples would be a Navcom radio, a Tanis heater, an ELT, or a magneto. They're attached to the engine, but they're not part of the engine. If you want to find examples of what an appliance is, just go do a search for appliances, for AD appliances, and you'll see different, what they consider to be appliances. .43 is the main regulation for maintenance personnel. So brush over that, just refresh our memory. 43 applies to aircraft with a U.S. airworthiness certificate. It applies to airframes, engines, propellers, appliances, and the component parts of the aircraft, life-limited parts that are removed from an aircraft. Special light sport aircraft, except for the part about 337s for major repair and alterations. That is not required for a special light sport aircraft. And it does not apply to experimental aircraft. Persons authorized to perform maintenance. and preventative maintenance, rebuilding, and alterations. In 43.3, these are the folks that can do maintenance, preventative maintenance, rebuilding, and alterations. Holder of a mechanic certificate or a repairman certificate. Reference part 65 for the privileges and limitations. It provides more information. A person working under the supervision of a mechanic or repairman, they can perform the work that his supervisor is authorized to perform. But the supervisor must personally observe the work being done to the extent necessary to ensure it's done properly. And there's some discussion and gray area, if you will, concerning this now with the modern technology we have, video technology. That's kind of being worked through right now, but must be available for consultation in person. Now, a person working under the supervision of a mechanic or repairman cannot perform an inspection. That's prohibited by 43.3D. They can assist, but they cannot actually perform the inspection. Others authorized to perform are repair stations, air carriers, a pilot. They can perform preventative maintenance only and only on Part 91 aircraft. They must own or operate the aircraft. A sport pilot can do preventative maintenance only and on special light sport aircraft only. They must own or operate the aircraft. And the regulation carves out some things that a pilot of a rotorcraft in a remote area can perform. Now, these types of pilots cannot even perform preventative maintenance. And the reason is because they're not authorized to return to service. So therefore, they can't do preventative maintenance. And that's recreational and student pilots. For those listening by phone, now, persons authorized to return to service. There's a difference between performing the work and then returning the work to service. It's covered under 43.7 and 65. These are the folks that can do it: airframe mechanic, power plant mechanic, IA, repair station, manufacturer, air carrier. This would be a Part 121 or a 13510 or more air carrier. They would be signing it off under their air carrier certificate number, most likely. Private pilot, as we just talked about, they can return to service, preventative maintenance only. There's the light sport aircraft repairman with the maintenance rating. Sport pilot, they must own or operate the aircraft, and it's for a special light sport aircraft only, preventative maintenance only. Oops, excuse me. Went one slide too fast. Now, performance rules. It's good that we review those. The regulations we call the performance rules for those authorized to perform maintenance are found in 43.13, 43.15, and 43.16. And they define the quality or standard we must achieve when working on aircraft. (43.13) says, and there's that mandatory language, shall use methods, techniques, practices prescribed in the current manufacturer's maintenance manual, instructions for continued airworthiness prepared by the manufacturer, or other methods, techniques, and practices acceptable to the administrator, except if you're doing work specified in the airworthiness limitations section of a manual or an ICA, you shall perform it in accordance with that section. And if you're performing an AD action, you follow the instructions in the AD. If you're working on an aircraft under Part 121, 129, or 135, you shall use the methods, techniques, and practices in the maintenance manual of the air carrier. And usually those are based on the manufacturer's manual, maintenance manuals and tech data, but sometimes an air carrier will develop their own procedure. Shall use the tools, equipment, and test apparatus necessary to assure work's completed in accordance with accepted industry practices. So if the maintenance manual says you need to have this particular type of equipment to do the work, that means you have to have that equipment or its equivalent, acceptable to the FAA. It goes on to say you'll do the work in such a manner and use materials of such quality that the condition, the end result, is at least equal to its original or properly altered condition. Now there's additional performance rules for inspections. And it says that you'll determine the aircraft and portions meets all applicable airworthiness requirements. I should have capitalized the word all, but I do want to emphasize that. Part 125, 135, and aircraft under 91-409E, inspections are performed in accordance with the inspection program of the carrier. And 4315 also spells out additional requirements for rotorcraft. Just, I guess they want to make sure that no matter what, you're going to inspect the drive shafts, main rotor, transmission, gearbox. And on an annual / 100 hour, says you shall use a checklist, and it must include the scope and detail of Part 43, Appendix D. And since you have to make sure it meets all applicable airworthiness requirements, you're also going to have to make sure there's no applicable ADs or airworthiness limitations, and make sure that life-limited parts have not reached their life limit. Reciprocating engines, there's a paragraph there that says you shall run the engine, make sure it meets manufacturer's recommendations, tells you what you're supposed to ensure. And then for turbine engine aircraft, it just reads a little bit different. It says you make sure it meets manufacturer's recommendations. Part 4316 covers airworthiness limitations, and this section of a manual is actually approved by the FAA. And you shall perform maintenance specified in the airworthiness limitations section or ICA in accordance with that section, or in accordance with a Part 121, 135 op specs, or a 409E inspection program. Now let's look at the privileges and limitations. This is all found in Part 65, Subpart D. A and P, airframe privileges and limitations, power plant, privileges and limitations, IA, and repairman. So an airframe mechanic, privileges and limitations. An airframe mechanic may approve and return to service an airframe or any related part or appliance. Remember, the appliance is something that's attached to the airframe. After he has performed, supervised, or inspected its maintenance or alteration, but you cannot do a major repair or alteration. And you can perform the 100-hour inspection required by Part 91 on an airframe or related to the airframe, part, appliance, and approve it for return to service. You may not perform or supervise major repair or alteration of a propeller, any repair or alteration of an instrument, and you can't exercise the privilege unless you understand the current instructions and you have recent experience. And a lot of people forget about the recent experience requirement. Within 6 months, you have to have done that action. And you cannot return to service a major repair or alteration. And those are defined in Part 43, Appendix A. Power plant reads kind of the same as the airframe, you're just going to be doing it on a power plant or propeller, or a part that's related to the power plant or propeller. And it excludes major repairs, major alterations. And in addition, you may perform the 100-hour inspection on a power plant or propeller or any part thereof and approve it for return to service. Now, an IA, they have all those privileges because IAs have to be both an airframe and power plant mechanic. So they have all those privileges we just looked at. But as you know, you are able to inspect and approve for return to service major repairs and major alterations if the work was performed in accordance with technical data approved by the administrator, not accepted, but approved. Has to have a stamp or some kind of an indication that it's approved. You can also perform an annual inspection and or perform or supervise a progressive inspection. Let's look a little bit, let's look at the IA parameters. For example, the duration of an IA. An IA expires March 31st of each odd numbered year. For example, 2021, 2023, coming right up, 2025. And it ceases to be effective whenever any of the following occurs. If it's surrendered, suspended, or revoked, or if the holder fails to meet the renewal requirements. And we're going to look at those renewal requirements. You cannot exercise privileges in year 2 if renewal requirements of year 1 were not met. You must take an oral examination first. So if you let it lapse in year 1, you've got to contact the FSDO and let them know, and they will give you an oral test. Hopefully you'll pass and you'll be able to keep exercising the privilege in year 2. Bottom line, don't let anything lapse. Now, an initial applicant criteria, that's the regulation that covers it. It's listed at the top. So the initial criteria is in that regulation. You have to be an A&P for 3 years. You have to be actively engaged for the 2 years prior to applying. Make sure your work was done on certificated aircraft. And those are the other requirements. Fixed base of operations, equipment, facilities, you have to have the data. And then you'll pass a written test, 50 questions, 3-hour time limit, minimum passing score of 70, and you can retake it after 90 days. So renewal, remember, it's good for 2 years. Renewal occurs in March of odd years. So that's coming up this coming March. And you're going to have to show evidence in March that you met the renewal criteria. You're going to use the IACRA application, most likely. I know in the San Antonio FSDO, that's what you're going to use. And I have a webinar that gives the step-by-step process for doing that. You can send me an email. I think it's available on socialflight.com. It's a video. We recorded it. And it's actually worth an hour of credit as well. It kind of takes you step by step through how to fill out the IACRA application. So the initial criteria, you still have to meet all that. Actively engaged, fixed base of operations, the equipment. So for renewal, you still have to meet those criteria. And the added thing is you have to have renewal activities in both year 1 and year 2. So we're going to cover those requirements. First, what does actively engaged means? There's the definition. You're going to show evidence that you were actively engaged. And the quantity of, the work you did can kind of help the inspector determine if you were really actively engaged. And remember, it's certificated aircraft only. Military aircraft doesn't count for this. Equipment and facilities. You have to have the equipment to do the work. This would be like hand tools, compression testers, cable tensiometers, things of that nature. You got to have the facilities to protect the aircraft while you're performing the inspection. And a fixed base of operation. That's just a place where you can be located in person during the normal working week. It does not have to be where you're exercising your IA authority. Your FBO could be your home, and then you're doing inspections in a hangar elsewhere. Inspection data. Well, we just went through a lot of resources that you can use where you can get the ADs, the ACs, type certificate data sheets, but you're also going to have access to aircraft manufacturers' manuals and ICAs, service bulletins, because ADs sometimes reference a service bulletin. So you'll have to be able to show that you have access to this inspection data. Here's a chart I made up to because I was a little confused over this. So I made up this chart to kind of show, what has to take place in year 1 and in year 2. So in each year, you have to do either 4 annual inspections or 8 major repairs or alterations, or 1 progressive, or 8 hours of IA refresher training, or an oral test by an FAA inspector. Make sure the training is FAA accepted training. And that would be an IA refresher seminar. We're going to look at that in a minute. Or FAAsafety.gov. There's a list of IA courses. A lot of them are free. And one question I get every now and then is, because the regulation is kind of confusing, it does not require one annual to be performed in each quarter or each 90-day period. As long as you have 4 annuals for the year, that counts. So let's look at a couple examples. Year 1, an IA did 4 annual inspections. Year 2, the IA had 8 hours of eligible IA training. And green, the requirement is met. And if you hear crinkling in the background, I'm getting a cough drop so I don't lose my voice. Here, the second example, year 1, the IA had 8 hours of authorized IA training. That sounds good. Year 2, the IA did 3 annuals and 2 major alterations. Nope. Doesn't count because you cannot combine the activities. Just the way the regulation has been written and interpreted, you can't combine them. It's either or. Most people, I believe, are meeting it through the annual inspections because, you know, it's hard to do 8 major alterations in a year, I think. Now, for IAs out there who are employed by a repair station, be careful because you can only get credit for the stuff you sign off using your IA number. Here's an example. Here's a sign off for an annual inspection, but they signed it off using the repair station number. So that's not going to count. So what is eligible training? Well, here's the list. If you go to the FASTEAM website, which is FAAsafety.gov, under the mechanics tab, there's I think it's called the maintenance hangar tab. There's an IA renewal course list. Also, there's training provided by manufacturers or their representatives for their TC or STC or TSO PMA product. Those ones don't require a course number, but it can't just be familiarization training. Like, here's the bathroom, here's where the fire exit is. You know, it's got to be technical or safety informative. And they have to provide you with a certificate of training. And another eligible training is FASTEAM or Office Manager IA renewal training event, and that's what we're doing right now. And there are courses at the FAA Academy in Oklahoma City that non-FAA employees attend, I believe, and they're eligible. Now, inspections authorized mechanics are charged with making a determination the aircraft meets all applicable airworthiness standards. So you must, you need to know what airworthy means. Airworthy requires 2 things. Somebody's raising their hand. Let me see. If there's any problems or issues. Okay. So airworthiness requires 2 things. 2 conditions must be met for an aircraft to be considered airworthy. The aircraft must conform to its type design And secondly, the aircraft must be in condition for safe operation. Now, I have 2 short videos on each of these topics. And I hope that when I play the video on my computer that you are able to see it.
Making a successful flying machine requires doing a lot of things right, as you can see. Here. Many people have tried to duplicate birds. The wings must be large enough and properly formed to develop lift equal to the weight of the machine and its pilot at the intended flying speed. The machine must have enough power and an efficient means of converting that power to propulsion in order to overcome its aerodynamic drag and maintain the intended flying speed. If it doesn't have enough power and propulsion, it'll never reach flying speed and thus will never fly. It needs stability and controls to set the angle and direction during flight. And of course, a head start won't help if the key design qualities aren't already present. And finally, the wings must be strong enough to support the total weight. Or in other words, it has to all hang together.
Okay, so that video is talking about type design, all the design features of an aircraft, and that's one of the elements of airworthiness. It has to conform to its type design. Now we're going to look at a short video on condition for safe operation. And as we watch it, I want you to put yourself in the roles of the people in this video. For example, one might be an aircraft owner, and the other could be yourself as an IA, telling the owner that, you know, this particular aircraft defect has to be repaired. And I know it's expensive, but it's not airworthy unless it's repaired. So just put yourself into that role as you watch this video.
Great. Cop, watch it! How fast are you going?
I can't tell. The speedometer's melting.
Pull over.
Top of the morning, officer.
Hi.
Is there something I can help you with?
What the hell are you driving here?
We had a small fire last night, but we caught it in the nick of time.
You have any idea how fast you were going?
Funnily enough, I was just talking to my friend about that. Our speedometer's melted, and as a result, it's very hard to say with any degree of accuracy exactly how fast we were going.
78 miles an hour.
78, huh? Well, yeah, I could buy that. Sure, I guess. You would know better than us, especially since we got a melted speedometer.
Do you feel this vehicle is safe for highway travel?
Yes, I do. Yes, I really do. I believe that. I know it's not pretty to look at, but it'll get you where you want to go.
Now, you got no outside mirror.
No, we lost that.
You have no functioning gauges.
No, not a one. However, the radio still works. Funny as that may seem, with all this mess, that the radio is the only thing that's really working good, and it's as clear as a bell. Don't ask me how.
I can't let you go ahead in this vehicle.
Can't what?
No, it's not fit for the road. The vehicle will be impounded until such time as it can be made safe for travel on state highways.
Okay, officer, I admit it. I broke the law, and for that I'm really sorry. I am. It'll never happen again. You got me there, and I won't argue with you one iota, I swear. However, if you impound our car, I'm going to be unable to get my friend here home in time for his Thanksgiving dinner.
Okay, hopefully you saw that video. It's one of my all-time favorites, but that's a good description of condition for safe operation. That car obviously was not safe to operate. So, as far as airworthiness, the airworthiness standards are the regulations that define the things that make an aircraft safe, such as the seat belts, circuit protection, firewalls, placards, etc. Now here we have a chart that shows what we're discussing. And the airworthiness standards are considered are called the certification basis. Some examples are the old car, part 3, FAR part 23, 33, 36, depending on what type of aircraft. The manufacturer's type design, the manufacturer builds the aircraft according to their type design. This would be covered in the type certificate data sheet, the drawings, the blueprints, etc. And they have to prove that their aircraft conforms to their type design. They have to demonstrate it, and they run a lot of tests to make sure that it meets the design criteria. Now, in the next few slides, we're going to discuss this first element of airworthiness: conformity to type design. So what is type design? It is defined in part 2131A, and it's the drawings and specs that show it conforms to its certification basis. Here's an example of a type certificate data sheet. You know, how do you know it conforms to its type design? Well, this is a good place to start. And the type certificate data sheet is a summary of the type design. Some people call it the birth certificate for an aircraft. This is for a Cessna 150 series. It's about 19 pages long. And here's the data plate on a door of a T210. And it tells what the type certificate number is. In this case, it's 3A21. Aircraft are type certificated under different parts. And this is the excerpt from that type certificate data sheet on the Cessna 150. And it says its certification basis is Part 3. But now look at a certain serial number and on, it becomes Part 23. So that is the certification basis for this model aircraft. Here is a excerpt from the type certificate data sheet for a Bell 407. Notice it says it's FAR Part 27. And the type certificate data sheet prescribes the conditions and limitations under which the product meets the airworthiness requirements. And we should note that if these conditions are not met or the limits are exceeded, the aircraft will not meet the airworthiness requirements. So going back to our Cessna 150 type certificate data sheet, notice it tells what engine is installed, the fuel, the engine limits, the propeller size. Now, if you know, if you use a different fuel or you put a different propeller on it, then it doesn't meet its type design any longer. Unless it's an approved alteration, like an STC propeller, or maybe they have a STC for using automotive fuel. Here is the section on the weight and balance. Notice it in this particular case, we're going to look at this later, but the Cessna 150 says the empty weight CG range is none. I just want to point that out because we're going to look at this later. And it lists the loaded CG range depending on the weight above that. Now, the question is, does deviation from the weight and balance affect the airworthiness of the aircraft? Of course it does, because if the CG is too far forward, you know, the aircraft is nose heavy and there would be insufficient elevator design, nose up force. So when you're doing an inspection, you must ensure the aircraft is within its weight and balance limits, because that's part of the type design. And of course, if it's out of CG, chances are it's going to crash. Been a lot of accidents caused by weight and balance problems. Going to do a little review of weight and balance here. Get familiar with it again if it's been a while since you looked it up. Notice the datum line on this Piper is the leading edge of the wing. Anything forward of the datum is a negative arm. Anything aft of the datum is a positive arm. Notice the definition for maximum weight, empty weight, the empty weight center of gravity, and useful load. Now, as a technician, you must update the weight and balance anytime you make a change to the weight and balance. Here's two really good references. Weight and Balance Handbook and AC 43.13-1B that we looked at earlier. Chapter 10 has a really good section on weight and balance. So if you remove or install an item, you must update the weight and balance record. Going to do a little review here. Remember, weight times the arm equals the moment in inch pounds. So if you install weight, you're adding pounds. That's a plus. If you remove equipment, you're removing weight, that's a minus. As for the arm column, if you are installing or removing an item that is located forward of the datum line, it is a negative arm. If you are installing or removing an item that is located aft of the datum line, it is a positive arm. And don't forget the rules for multiplication. Negative times positive is a negative. Negative times negative is a positive arm, and a positive times positive is a positive. So if you just look at one example, like the strobe removal over there in the chart, we have a negative. They removed it, but the arm was a positive, so negative times positive, they end up with a negative moment inch-pounds of 105. So you'll add or subtract all the weights to the previous weight, and you get the new weight, which is what I've highlighted here in red. The original empty weight was 2350. After they added and removed all the equipment, it ended up being 2327.5. So it's a little bit lighter, and they gained a little bit of useful load. And then you add or subtract all the moments to the previous moment, and you get a new moment in inch-pounds. So after they do all the math, they end up with 55,925.8 inch-pounds. Then once you have that information, you can calculate the new arm or CG. And the new CG is the moment divided by the weight. So there's the moment divided by the weight. They come up with a new arm of 24.03 inches, and it's a positive, so it's aft of the datum. Now, remember when we looked at the type certificate data sheet on that Cessna, if they list an empty weight CG range, if it's listed, which it wasn't, it said none on that Cessna 150, it means that if the empty weight CG is located within this range, it's impossible to legally load the aircraft so the loaded CG falls outside the allowable range. But in most aircraft, it's going to say none. And if it says none, then the IA or mechanic must calculate the forward and aft adverse loading. You may have to add ballast. And reference the AC that I showed you and the weight and balance handbook. They have real good descriptions of how to do this if it's been a while since you've done it. But you need to calculate like worst case scenarios to make sure that the alteration you did is not going to allow the pilot to load the aircraft and create a situation where the loaded CG is outside of that range. Keep in mind that helicopter weight and balance is even more critical than a fixed wing, and most of the time they also have lateral calculations that must be made. Now, the type certificate data sheet is also going to state something about placards. Here's a statement from the, I believe this is from that Bell helicopter type certificate data sheet. Talks about a placard that must be displayed in clear view and in front of the pilot. And it also says all placards required in the approved flight manual must be installed. So an aircraft is not airworthy unless all required placards are installed. And probably one of the most common things an FAA inspector will find on a ramp inspection are placards that aren't there, or you can't even read them. Some examples would be on the compass correction cards, the fuel filler placards, on the top of the wing. A lot of times they get all damaged and aircraft gets painted and they don't put the placard back on. The baggage compartments probably have a placard of the maximum weight, and that's very important. So make sure the placards are there. Now we're going to look at what equipment must be installed in an aircraft to maintain airworthiness. Remember, it must conform to type design. So there is some equipment that's required by the type design and it cannot be removed. So going to start with the equipment list and the type certificate data sheet. Every aircraft must be delivered with an equipment list, and that list must be kept up to date as equipment is added and removed. It's very important. Certain types of operations require specific equipment, and even though it's more of an operational concern, you should be aware that VFR and IFR types of flight require different types of equipment. That is in 91.205. Some airspace requires certain types of equipment. For example, ADSB is now required. Any place a transponder is required. Transponder, of course, is also required in certain airspace. There are very few places you can fly these days without an ADSB and a transponder. There are exceptions for aircraft that don't have a power source, for example. ELT is required by 91.207. There are some exceptions. For example, an ELT is not required for scheduled operations or training operations within 50 miles of the airport. Single seat aircraft, while the ELT is removed for repair. So if you're in doubt, look up the actual regulation. Now let's continue to look at the equipment that's required by the certification basis. Type certificate data sheet for the aircraft is going to say something about the equipment and the original equipment list that's provided by the manufacturer. So here we're looking at that 150 again. Says that the basic required equipment as prescribed in the certification basis has to be there. And they also list that the current flight manual has to be there. And this one even lists a stall warning indicator. So if you're doing an inspection, you want to make sure all this equipment and the flight manual is there, because if it does not conform to its type design. Here is an extract from CAR Part 3. Required basic equipment for this Cessna 150 is in paragraph 3.655. And then if we look at that paragraph, you can kind of see the list of equipment that must be there. Flight and navigational instruments, power plant instruments, oil pressure indicator, oil temperature indicator, and so on and so forth. The airplane could not be flown without this equipment unless a ferry permit is issued, because the aircraft is not airworthy with any of this equipment missing. Here it is for the Bell helicopter. And it also lists an engine out warning system. And I once came across an operator who removed and placarded a mast moment indicator on I think it was a BO 105 helicopter. It was a Part 135 operation. And they removed and placarded the mast moment indicator system. And they did a 337 for that. And I looked in it, the mast moment indicator is in the MEL. So I said, well, why did you remove this and disable this system? And the director of maintenance said, well, we can't get the part. It takes about 6 months to get the part. We can't get the part, so we just placarded, removed the system and placarded it. And the regulations say if there's an MEL, you have to follow the MEL. So unfortunately, the MEL only gave them 10 days for this to be, the repair category was 10 days. So there's no way they could MEL it and get it repaired in 10 days because the part was not available. Well, this was not authorized because that mast moment indicator is part of the type design. I went and contacted the manufacturer, and they said that is part of the type design, so it cannot be removed. It has to be there to meet the certification basis. So the fleet was grounded until such time as they got that fixed, and the manufacturer actually came out and really helped them, and they came up with the stuff to fix it, and they got them back up to speed. But it resulted, I did a safety recommendation because the MEL and the maintenance manual really weren't helpful in this situation. And it ended up, they took it from a category 10 days to 120 days on the MEL. And so it worked out in the end, but just a good example of you can't just remove something if it's part of the type design. I just, for fun, did a search for this part this morning, and there's the mast moment transmitter that they couldn't get. There's one on eBay. Here's an equipment list for a 172. This is kind of a newer aircraft. This one has the Garmin, I think it has a Garmin G1000 system. And notice that this is the comprehensive equipment list. It says R means it's required for certification. So if it's got an R beside it, gotta be there. They really get detailed on the altimeter. It's got to be a sensitive altimeter with 20-foot markings and so on and so forth. They even list the part number. There's also a kind of equipment list, a KOEL, for this particular aircraft. And I find it interesting that notice the kind of operation. You don't have to have VHF comms for VFR day or night. It's not wise, but they aren't required. And this is usually, this chart kind of correlates with 91.205. So what about maintenance? It's on our chart. Unless the aircraft is properly maintained in accordance with Part 91 and 43, it is not airworthy. So an important part of this element is your documentation. Remember that maintenance actions are intangible after the fact. Nobody will know if the aircraft was inspected or a repair action was accomplished after it's done. You can't tell if, you repaired the internal workings of an engine just by looking at it. So that's why it must be recorded in the maintenance log. And if it's not recorded, you have no proof it was accomplished. This is why the FAA makes falsification of records a very serious offense. So let's look at the airworthiness certificate. There's what block 6 says. The certificate is valid as long as the maintenance, preventative maintenance, and alterations are performed in accordance with Part 21, 43, and 91. And the aircraft is registered. Registration expires every 3 years, so make sure you check the registration card and the airworthiness certificate when you're doing an inspection. So let's look at the second element of airworthiness, and this is condition for safe operation. Now we know that wear and deterioration occurs over time and use. And, you know, some aircraft have more time, they're older, and some have more use, like flight school aircraft. So there's going to be more wear and tear on those aircraft. So keep that in mind when you're doing an inspection. So since condition for safe operation is part of airworthiness, what is safe? What is safety? And there's a definition I got from a dictionary. It's a condition of being safe from undergoing or causing hurt, injury, or loss. So when does normal wear and deterioration become an unsafe condition? When normal wear and or deterioration causes the part to no longer meet its type design, the aircraft's no longer in condition for safe operation. Here's some examples. A tire worn beyond limits, a seatbelt frayed so it doesn't provide the designed protection, brake pads worn down so metal is on metal. Keep asking the question, and one way to answer it is from the old adage, it's an accident waiting to happen. Have you ever heard that one? Well, when you see an accident waiting to happen, it's probably not in condition for safe operation. I'm impressed with this because he's got the truck really well supported with the beams. And he's even got a chock in there, or he's got a rock holding the tire. The only problem is it looks like he's welding the gas tank. Another definition would be if a part is likely to fail due to wear and deterioration, and its failure will cause an accident or loss, it is not in condition for safe operation. It's not safe. So what about damage? Damage can also cause a part to no longer meet its type design. It's no longer airworthy. You have to reference the manufacturer's damage limits. Or if damage causes a part to no longer be in condition for safe operation, it's no longer airworthy. Let's look at some real life scenarios. This is actually an aircraft in the FSDO, our district, I think, being used in flight instruction, I believe. And notice the dents on the leading edge of the wing. So is the airplane airworthy? Well, it has to be considered unairworthy until a determination is made by a properly certificated person. And this inspection should then be entered into the logbook so that others will know that it's been inspected, it's been found to be airworthy. This might be an example of the entry. Inspected the leading edge dent located on the left wing. Just tells where the dent was. Found to be negligible in accordance with the Cessna Service Manual, and there's the paragraph. Here's another one. Seats in a Cirrus aircraft observed by a ramp inspection. This is a real life scenario in our district. Has this reached the point of an unsafe condition or non-conformance to the type design? Does this pass an inspection? Well, there's part 43, Appendix D. There's what it says. Each person performing an annual or 100-hour inspection shall inspect seats and safety belts for poor condition and apparent defects. So this obviously fails, and it's not airworthy. This reminds me of the car that John Candy was driving. So here's another one, a scallop tire. It's not in condition for safe operation. It's not even really round anymore. As far as I know, tires are supposed to be round per their type design. How long would you drive with this on your car, let alone an airplane? Here's a good AC for tire maintenance, 20-97. Talks about inflation, maintenance, and removal of aircraft tires. There's another good resource, is the Goodyear tire manual. If you go on their website, you can download this manual. Here's a seat belt. Is this in condition for safe operation? It's frayed. It's not in condition for safe operation. Now, some might say this looks like normal wear and tear and deterioration. But how can you be sure this is going to withstand the G-forces in a crash that are specified in the certification rule? That's the question. There's the certification rule for a Part 23 aircraft. Goes to great length onto all the specifications that the seatbelt has to meet. So upon further inspection, you notice that it's frayed completely through. So it's definitely, it fails both criteria. It's not in condition for safe operation, and it doesn't meet its type design. This one probably more, it meets the second, doesn't meet the second criteria. It doesn't meet the type design. It's probably not going to cause an accident or loss. I mean, after the fact, after the accident occurs, if this thing breaks, then obviously it could cause serious injury or death, but it just doesn't meet the type design. Flying unairworthy aircraft. Can unairworthy aircraft be flown? No. Unless a special flight permit is issued by the FAA. Can unsafe aircraft be flown? No. Because a ferry permit cannot be issued if an aircraft is not safe. It has to be inspected and in condition for safe operation for the ferry flight. So ferry permits covered under 21-197, you might be asked to, make this condition inspection for a ferry permit. And they're issued to US registered aircraft that may not currently meet applicable airworthiness requirements, but they are capable of safe flight. Make sure you pay close attention to the discrepant area for damaged aircraft. And keep in mind that an engineering evaluation or special test may be required to determine that the aircraft is capable of safe flight. You may not be able to tell using your own expertise or knowledge or equipment. Might need to get the manufacturer involved. You might have to get engineering involved. Common reasons for the ferry permit are overdue inspection, damage, expired life-limited parts, export or evacuation. Now, we're going to look at a case study for a ferry permit that involved a lightning strike. This was on a Challenger 300. The aircraft was struck by lightning. There's some of the damage. Horizontal stabilizer, trailing edge on the pylon, the flap fairing. There was a black mark. And then on the radome. Well, since it was struck by lightning, the obvious thing to do would be a lightning strike inspection. And the mechanic performed the lightning strike inspection. And there's what the manual says. It should be done before the next flight. Failure to do so may result in the aircraft operating with undetected damage. So the mechanic made a few errors in this process. Notice it says, remove any damaged panels and examine the internal electrical and mechanical parts for lightning strike damage. So here we find the flap fairing, and there it is with the panel removed. Well, this aircraft was actually flown on a ferry permit to a different airport for the repair. And underneath the fairing at the airport where it was being repaired, they actually pulled the panel and they saw this damage. And that's on the flap control linkage. So, due to the critical function of flight control linkage, this part should have been replaced before the ferry flight. And it should also be noted that the Part 135 operator had identified flap control linkage as a critical part. It was on the RII list. So we don't think the mechanic that signed off on the ferry permit and the lightning inspection actually removed this panel. In addition, the horizontal stabilizer had this damage on it. And if you look at the maintenance manual for horizontal stabilizer trailing edge, it says no damage allowed. And the mechanic did not document the horizontal stabilizer damage, just documented the radome and the left-hand wing pylon trailing area screw. And if you look, it's very similar to what the pilot wrote up, pretty much the same thing. Of course, the pilot couldn't see the horizontal stabilizer from the ground, so he didn't know that damage existed. Looks to me like the mechanic just repeated what the pilot wrote. I don't know how thorough of an inspection was done. There's the write-up to get it from the one airport to the other. Condition inspection for safe ferry flight. Now here's order 8130.2. Says under special cases for damaged aircraft, it may require engineering evaluations or tests. And this aircraft, the damaged horizontal stabilizer, it did require engineering inspection, and they had to make a repair using a procedure developed by the engineers. The lesson learned here is follow the manual, remove the panels if you're told to do so, and if you can't make the safety determination, then don't. Have it evaluated by engineering. Well, you should now have a really good understanding of what's required for an aircraft engine or propeller to be airworthy. And during the next hour, we're going to look at factors influencing airworthiness. And so factors influencing airworthiness, type design changes. If it's an approved change, then the aircraft remains airworthy. If it's an unapproved change, then the aircraft is not airworthy. We also see STC installed equipment oftentimes, and an STC, supplemental type certificate, is an approved change to the type design, but it must be done properly. It could also impose additional maintenance requirements. There could be instructions for continued airworthiness. And sometimes those say, you know, there's an inspection due every 100 hours or whatever. You also have sometimes equipment installed by the FAA 337 form field approval process. And field approved items must also have ICAs. And so if the equipment is installed that requires a field approval or an STC, but none was obtained, you can't find the documents in the aircraft records, then the aircraft is not airworthy. So it's something you want to be watching for. When performing an inspection, you must ensure that any inspection called out in the ICA of an STC or 337 are accomplished. So it's not only Part 43, Appendix D, you also have to look at ICA inspections if there's an inspection in the ICA. Here's an example of a Garmin transponder maintenance manual installed under this STC. And here's the instructions for continued airworthiness. Notice most of them are on condition, but it does have a 12 calendar month inspection and 10-year or 2,000 hour electrical bonding test. This is just one example. I have seen ICAs that every 50 hours you have to inspect something. There's also pilot-induced factors. There's hard landings. Looks like the wing got bent on that one. Airspeed exceedances. Those lines are on there for a reason. Usually they correlate to the parameters listed in the type certificate data sheet. If you over redline the RPM, you cause engine damage. There's over temp and over G. Pilot-induced factors. I once saw a seatbelt left hanging outside of a door of an airplane, and it took off, and the seat buckle just really beat the heck out of the aircraft skin. They can use the wrong oil during an oil change, or maybe put the filter on improperly. There's an example of that. They put the wrong filter on that aircraft and the engine came apart. Exceeding the useful load or out of CG loading. Do you think all that baggage is going to fit? Looks like my wife packing for a 2-day trip. We've also seen wrong or soft surface landings. Sometimes the flight manual prohibits a landing on a gravel surface, for example. And how often have we seen an aircraft nose over because it's grass strip and it rained and it's soft and tips over. Don't forget the dirty dozen. Mechanics can also do things that adversely affect airworthiness. We're all human. We all make mistakes. There's many reasons for mistakes, but they do occur. Let's run through the dirty dozen real quick. This one's lack of communication. I guess the day shift can finish screwing on the panel. Well, this has caused a lot of fatalities where a panel has been left off an aircraft. Complacency. I've looked back there 1,000 times and never found anything wrong. I think the little quotations on these are really good. Lack of knowledge. This is the third one to bend. What's going on? Well, there's probably something wrong that you don't know about. Distraction. Of course, the big one here is cell phones. Hey, your wife's on the phone. Pick up a gallon of milk and a loaf of bread. Lack of teamwork. The rest of the crew will be here soon, but I'll bring this one in myself. Yeah, some jobs require more than one person. Fatigue. I'm glad when this double shift is over. Lack of resources. We have no stock of left skids, so I guess this will have to do. I think this is a big one. The owners are, they want their airplane and you lack one little part to finish the work or the inspection. Pressure, that's when the pressure comes in. Hurry up or we're going to be late again. Lack of assertiveness. Well, when an owner or a boss is telling you, they own the aircraft and I say it's not a bad leak. Well, who's signing on the bottom line? Who's responsible? Stress, all these things really add up to stress. There could be stress at home too, causing problems. Lack of awareness. All the regulation says was install it where it's easily accessible. And norms. Never mind the maintenance manual. It's quicker the way we do it here. Well, they're showing a forklift holding that aircraft engine, and this actually caused a major crash of an airliner. They were using a forklift and at the end of the shift, and then overnight the forklift hydraulics sagged down a little bit and it actually cracked the wing pylon mounting bracket. And that engine came off later and it killed everybody, as I recall. The manual did not call for lifting it with a forklift, but they found a workaround. Not good. So mechanic-induced factors, here are some of them. Installing the wrong part, improper torque, or a non-calibrated torque wrench, or maybe not even using a torque wrench at all. I won't read them all, but you can see them here. The loose B nuts and the engine controls improper and the cylinder torques. Those three were the three leading causes of accidents after maintenance, and they were part of our topic of the quarters, I believe. So you walk up to the airplane and you look, and here's the handle being held on safety by safety wire. This is an actual finding in our district. Wrong attachment hardware. Is this in condition for safe operation? Yes. Probably safe to operate. I don't think the handle's going to fall off. If it did, it's probably not going to cause an accident or loss, unless it hits somebody in the head. But is it airworthy? No, because it does not conform to the type design, unless the manual shows some safety wire here. So it's not airworthy. It fails the test of conformance to type design. You know, if you start allowing the substitution of hardware, where does it stop? There's a cotter pin installed on the door, and on the right is incorrect seat stop hardware. Oh, here's an example. Technician installs a new XM weather unit, attaches the power wire to the terminal on the flap circuit breaker. Or instead, he just attaches the wire directly to the electrical bus with no circuit breaker. Now, why do both of these actions make this aircraft unairworthy? Boy, have you ever looked behind the panel and seen about 4 I terminals on a circuit breaker? I have. You wonder, where are all these wires going from one circuit breaker? Well, it's not airworthy, does not meet the type design, and it will not be in condition for safe operation. And here's the certification basis, the rule. 1, you have to have a circuit protection device in all electrical circuits. That doesn't mean put them all on one circuit breaker. And also, if it's essential for flight safety, it can only be used, it cannot be used to power other circuits. So, you know, flaps, pretty essential for flight safety if your flaps don't work. So it should not be attached to the flap circuit breaker. Only the flaps should be attached to the flap circuit breaker. There's also environmental factors. Here's the ones I could think of: salt water, blowing sand, snow loads. I've seen airplanes with 3 feet of snow on the horizontal stabilizers and the nose was 3 feet in the air. Ice, heat, cold, and ultraviolet. UV really causes a lot of damage. Wasp nests in the pitot tubes. That happens quite often. They find out when they're not too far down the runway and they don't have any airspeed. Rain or moisture in the pitot-static tubes and corrosion. So we get an aircraft that's factory new, has the initial type design, and the type design can be properly changed by an STC or field approval. Aircraft remains airworthy. Or the type design can be improperly changed. Aircraft is no longer airworthy. Normal wear and tear occurs. Eventually, that causes parts to no longer meet their design specs. Aircraft is no longer airworthy. Maintenance occurs to repair the defects and the airworthiness is restored. That's where you come in. Inspections are done. Again, this is your role to identify and correct defects. Life limited parts are replaced, hopefully before they fail. That's the whole idea. And then we saw that pilot and mechanic induced errors and environmental factors can affect the type design and the airworthiness. ADs, ICAs, and service bulletins are issued to correct problems. A lot of times these come out of the Aircraft Evaluation Division. They monitor the in-service of, the safety in service of aircraft, and they'll issue these things to correct problems. But eventually, all aircraft end up in the boneyard when parts are no longer available or lifetime limits are reached. So that's our discussion on life limited parts. Let's summarize what we talked about airworthiness. An aircraft must conform to its type design. You're going to want to reference the type certificate data sheet, the manuals, STCs, if there are any, and the weight and balance information. Make sure there's no unapproved modifications, no unapproved parts. Make sure the required equipment is installed. Remember the equipment that had the R beside it in the equipment list or on the type certificate data sheet? Make sure life limited parts are replaced when they're supposed to be replaced. Look for damaged parts that no longer meet their type design. Secondly, aircraft has to be in condition for safe operation. That means the ADs are complied with and there's no excess wear and deterioration. You have to make the judgment call. Okay, next we're going to look at maintenance records, what to keep and for how long. The arrow is showing records that have to be retained until the work is repeated, superseded, or for 1 year. And that is records for maintenance, preventative maintenance, alterations, and all inspections. The 91, 411, 413, that's for 2 years because that's a 2-year requirement. So obviously you have to keep those for 2 years. And that's the transponder altimeter testing. And this list of items is considered to be permanent records, and they must be transferred with the aircraft. And those are all listed there. Records of total time in service for the airframe, engine, propeller, and each rotor, and the status of life limited parts, time since last overhaul for items that are required to be overhauled, current inspection status, current status of applicable ADs, copies of FAA Form 337. And last, if an IA provides an owner with a list of defects, they have to retain that list until they're all repaired and returned to service. So let's look at some maintenance record entries. (91-407) requires it. It says that no person may operate an aircraft after maintenance unless the record entry has been made and it's been approved for return to service under 43.9. 43.9 requires it. So each person who does maintenance must make an entry. What does a proper maintenance record entry look like? Boy, until you've reviewed a lot of different logbooks, when I'm sure you have, as you inspect different aircraft and you do your research, I'm sure you've seen some pretty shoddy logbook entries. Don't be one of those people. Maintenance record entry, a description of the work performed. That's probably the biggest one that people just don't get enough detail or don't make a good description. The date, that's easy. The name of the person who performed the work and the signature and certificate number of the person approving the work. And remember, you're only approving for return to service the work that you performed. You're not saying the entire aircraft is airworthy if you just change the tire. You're saying that the work you did is airworthy. So here, is this a good maintenance record entry? Change the oil, added 8 quarts. They got the date, total time. Let's run through it. Got the name of the person that performed it, the signature and certificate number. Yes, all the elements are there. That's a good entry. Sometimes 2 names are required on a log entry because you can have a person that performs the work and that can be a different person than the one that's approving the work. Here's an example of that. There's the regulation that covers it. And this was done, the person that performed it is named I Want to Be a Tech. And the person that approved it is I'm a Be Good. It's an ANPIA. So here's an example of that. But not for inspections. Remember, inspections, you have to be done by an IA. An annual inspection has to be done by an IA. It can't be performed by somebody else. They have to actually perform it. Inspection record entry is a little different than a maintenance entry. Type of inspection and a brief description of the extent of the inspection. The date, aircraft total time in service, signature, certificate number, and the kind of certificate held by the person approving for return to service. And then there will be a certification statement. Sure, you've all seen that and probably made many of those entries yourselves. And the approval for return to service for an inspection certifies that the aircraft or portion thereof under inspection meets all applicable airworthiness requirements. And we've been looking at that for the last several hours. All those things that you have to look at when you're signing off an inspection. Remember, there's the performance rule for inspections. And don't forget the 2 elements that have to be met for an aircraft to be airworthy: conformance to type design and condition for safe operation. Where do you make the inspection log entry? Generally in the airframe logbook, but if the aircraft has a propeller log and an engine log, the entries will be made in those logs. There's 4311. And it says you'll make an entry in the maintenance record of that equipment. So make sure you put it in the correct logbook. Let's look at another one. Is this a good inspection record entry? There's the type of inspection, brief description, and the extent of the inspection. Oh, that's pretty vague right there. Inspected aircraft. The date, well, the date's there. Airframe hours are missing. Signature, certificate number, and the kind of certificate are there. No certification statement. So no, it's not a good entry. Now here's another one. Let's take a look at this one. Let me look at, like, still this person is not, chat with everyone. Trying to help the gentleman that's having trouble hearing, make sure I don't, for some reason, have him muted. Just bear with me, folks, please. Let me find. Yeah, that's not even a setting that I can control. Sorry about that. I don't think it's on my end. So is this a good inspection record entry? Let's take a look. Got the type of inspection. It's an annual. Got the date. Got the airframe. This should be total time in service. There's the certification statement. I certify. And it says it was found to be in airworthy condition. And this is an annual, and this is not an IA inspector, just an A&P. So it would have been good, but it's not, because only an IA can perform an annual. Would be nice to have the extent of the inspection too, but normally annual is sufficient in the description. Let's look at one more. It's got the type of inspection and the brief description of the extent. It's a 100-hour inspection. They used 43 Appendix D. There's the date, time, signature, certificate, and kind of certificate. It's got the certification statement too. Certifies that it's in airworthy condition. So, and a 100-hour can be performed and returned to service by an A&P. So yes, this is a valid entry. So what happens if you do an inspection and you find discrepancies? Well, 4311 requires a discrepancy list be provided to the owner. This protects the technician, the IA, or the A&P if it's a 100-hour, who performed the inspection, and it informs the owner of the discrepancies. Here's a log entry. Notice that there is no certification statement saying that it's approved for return to service. It just certifying that it has been inspected. And the list of discrepancies and unairworthy items have been provided to the owner. There's no approval for return to service. Here's a sample of the letter that would be given to this owner. Completed an annual on your aircraft. Make sure you identify the aircraft, model, serial number, tail number, and be specific on the discrepancies. Now, what does the owner have to do? 91.7 says no person may operate a civil aircraft unless it is in an airworthy condition. So he's got only a few options. Like, he can ferry it, fix it, follow the MEL if there is one, and he's been issued a letter of authorization, or he could follow 91.213 for removal, deactivation, and placarding of the item if it meets the criteria specified in that regulation. Okay, next is record of overhaul and rebuilding. This is covered under 43.2. The big difference here, just be careful when you describe something as being overhauled or rebuilt. The main difference is in the testing. In an overhauled unit, it's tested in accordance with approved standards and technical data, or FAA acceptable data produced by the holder of a TC, STC, PMA, or TSO. But for a rebuilt unit, it's tested to ensure it meets new tolerances and limits. So it meets new part specifications. That's the main difference. And a part cannot be identified as overhauled unless it's the approved overhaul manual is followed verbatim. According to a legal interpretation in 2015, a subcomponent of a larger assembly that is being overhauled does not have to be disassembled beyond its normal state, or if it would damage the subcomponent. The legal interpretation also reiterated that the overhaul manual must be followed verbatim. And if the overhaul manual does not direct you to disassemble the part, then it is not required. So bottom line, just make sure you're following the overhaul manual. Falsification of records. Caution. An FAA inspector has very little flexibility on what action to take when there is falsification of records. Don't do it. We now have compliance action philosophy in the FAA, but that's usually not an option for falsification of records. Often we must do an enforcement, and it usually results in the loss of your certificate, and a lot of times it's an emergency revocation. And again, for really all other offenses, unless it's negligence or criminal, compliance action is always used if you're willing and able to comply. We just want compliance. Here's an example of falsification: signing off work steps or tasks that you never performed, making an entry for an inspection that you didn't perform, life-limited parts records falsification. You know, with the supply chain problems we're having now, that's probably a lot of incentive for people to falsify parts, identification plates, and life-limited documents. Changing a date, like a 91-411-413 date. I actually saw an IA lose his certificate because he changed the date on one of those checks, and the owner pressured him into changing the date so they would be in compliance so they could get one revenue flight in. Just never do that. Just be truthful and accurate. Here's the regulations that cover parts. We could do a whole presentation just on parts, but I just want to review briefly the parts. Here's what a false and misleading statement is defined as: statement intended to deceive, falsely represent the material, or omit pertinent information that would otherwise deem the product unacceptable for installation on a type certificated product. Part 3 came out not too long ago. Well, okay, it has been quite a while. In 2005, and it makes false and misleading statements illegal and subject to criminal prosecution. The marking requirements for life-limited PMA, TSO, and critical parts can be found in Part 45, Subpart B. Part 21 This is the requirements to manufacture parts. Here's a really good AC for, if you're not familiar with this advisory circular, I highly recommend you take a picture of this screen and download this AC. Actually print it if you want. It has a really pretty much everything you need to know about parts. What is an approved or acceptable part? Here's a list. There's a bunch of different ways that parts can be approved or acceptable. You know, the parts that are under the production certificate, that's everything that was submitted to the FAA as a, here's your airplane and here's all the parts, and they get their production certificate. So all those parts that were on it, those are approved. Produced under a type certificate, produced under STC, PMA, TSO, individual owner produced parts, or produced by a repair station, and it's quite a pretty big list here. Number 11, produced in accordance with established industry or U.S. specifications, nuts, bolts, and hardware, such as Army, Navy, or military specification parts, or the old ANMS NAPA parts. What's NAPA? Oh, NAPA stands for not approved part for aviation. No, not really. I think it's North American Parts Association, but yeah, don't get any parts from NAPA or AutoZone. So what is an unapproved part? Any part that fails to meet any of the approval requirements in 21.8 or 21.9. And sometimes an AD will actually prohibit the installation of a part. Here's one that prohibits the installation of this particular Cessna hydraulic hose. Here's a nice little chart from AC 2145 showing approved category, acceptable category, and unapproved. Well, let's do a little case study on a unapproved part that I experienced. This FAA 337 form was sent to the FAA for approval. Remember, that's one way to get approved data is you submit this form and the FAA looks it over and approves it in block 3. Then it becomes approved data. Let's take a closer look. It is for a Piper PA-28. And there's the IA check, and it's going to be signed off by an IA, and they can approve a major alteration. Here's the description. They replaced 3 existing OEM lamps with 3 Aerolites LED style lamps. Now, this particular Piper had a STC done that actually installed the wingtip lights and the lower engine cowling. So I looked up the STC and it does list that model, so that's fine. But then I got to thinking, is just replacing a lamp with a different type of lamp a major alteration? Kind of got me thinking there. I continued my review and I saw that this Aerolites, oh, there's a picture of the aircraft STC, added the wingtip light. And if dig around on their website, all over the place it says it's not approved. It's not FAA, PMA approved. You look at the questions. It says, nope, it's not legal, not approved for certified aircraft. So the actions that were taken were notified the owner that this light is not eligible for installation on a type certificated product. Reminded them that both the owner and the installer has a responsibility to ensure parts are eligible for installation. Because remember the performance rule 4313. And I believe I put a note that if the lamps that they're installing in the existing sockets were approved or acceptable parts, you would not need a 337, since it doesn't meet the criteria as a major alteration or repair as defined in Appendix A. As long as the lamp is approved and it meets the type design, that would really not be a major alteration. And I did find one that is approved. You could have put those in, but they're $274 a piece. And I don't know if you noticed the price on the other one. I think they were $79. It costs money to get these things, to get that approval. So they charge more. Let's look at life limited parts. We've looked at approved parts, unapproved parts. Now we're going to look at life limited parts. Here's the definition from 4310. Any part for which a mandatory replacement limit is specified in the type design, the instruction for continued airworthiness, a maintenance manual. Here's an example I found. It's hard to find an example on a fixed wing aircraft, but I found this one, life limited windshield and rear cabin top windows, side windows, and the ice detector light lens on a Cessna P210 has to be retired at 13,000 hours. Helicopters have lots of life limited parts, as you know. Here's a Bell helicopter, Bell 206 airworthiness limitation schedule. A lot of times this is found in Chapter 4, has the whole list of items that are life limited. So 4315, remember that it has to meet all applicable airworthiness requirements if you're doing an inspection and returning it to service. And life limited parts would certainly be part of that. And 91403 makes the operation of an aircraft illegal if the mandatory replacement times, inspection intervals, and related procedures, if they're in an airworthiness limitation section of the maintenance manual or ICA, or in an inspection program for those aircraft that have an approved or accepted inspection program, or contained in FAA op specs. Life limited parts that can be expressed in the number of cycles, number of landings, the length of time in service, calendar time, or a combination of those. The disposition of life limited parts, the goal here is to deter the installation of the part once it's reached its life limit and to track the life status of the part. And they put the onus on the person who removes the life limited part. And they have to do one of those 6 things that are listed. It has to be tracked with a record keeping system, a tag or a record attached to the part, non-permanent marking, permanent marking, segregation, or mutilation. Those are one of the 6 things that has to be done. If you just temporarily remove a life-limited part, those 6 previous controls are not required if the life status of the part has not changed. The removal and reinstallation is performed on the same serial numbered product. In other words, probably an airplane. You take it off, put it back in the same aircraft. And the product does not accumulate time in service while the part is removed and sitting on the shelf. So that's the rule. Now, again, each person who removes a life-limited part from a type certificated product and later sells or transfers that part must transfer it with the mark, the tag, or other record used to comply with this section, unless the part is mutilated. So I guess here's where you can take out your frustrations. You can mutilate the part before it is sold or transferred. And again, the goal is just to make sure it's never reinstalled. On an airplane, you could put it on your tractor. I'm going to press on for another 5 minutes here because I don't want to run late. And we're going to start the section on airworthiness directives. And in this section, we're going to look at 3 case studies of where missed ADs caused accidents. We're going to look at who performs ADs, who's responsible, how to record them, how to track them. Yeah. Okay, understanding AD responsibilities. These are our objectives, the performance and the record keeping. Understand the importance of installing only approved parts and correct parts. And an increased awareness of AD pitfalls to avoid and prevent accidents related to AD compliance. The serious side of airworthiness directives. Here's an AD. This is an example. You know, a lot of times ADs are prompted or because of fatal crashes, just like putting the traffic light up after somebody gets killed. Unfortunately, you know, you've probably heard the saying that a lot of the regulations are written in blood. Sometimes the ADs, you can think of them the same way. There's a number of accidents that involve a mechanical failure that can be traced to an AD that was missed or improperly complied with. This is the example of where the main rotor hub strap pins on some UH-1 helicopters was involved. Our first case study here today is involving Cessna 185. The accident occurred August of 2019 in Michigan. In cruise flight, engine lost power. It was a forced landing. They hit the electric wires, and you can see the airplane in that picture. It landed inverted, and there's the picture again. Believe it or not, there were minor injuries. It's hard to believe, but the airplane was destroyed. A pilot and 3 passengers. Probable cause from the NTSB. Maintenance personnel's failure to properly align the crankshaft during an engine reassembly in 2011. And this led to fatigue failure of the crankshaft and the loss of all engine power. Now, there was an AD from 2000 that was not accomplished. Now, when was the date of this accident? 2019. And there was an AD back in 2000 that was not accomplished. That AD required a metal sample to be sent in for testing. And the post-crash testing of the crankshaft showed that it did have improper material used during manufacture. There's the failure. In '98, this engine was rebuilt by the factory and the crankshaft was replaced. There's a copy of the record. Crankshaft replaced in 1998 by Continental Motors. Then in April 2000, a service bulletin was issued because they had 11 fractured crankshafts. An AD was issued and it incorporated the service bulletin. That made that service bulletin mandatory. And it required the core sample to be taken and tested. And if the test failed, you had to replace the crankshaft. So this AD was not complied with. The mechanic entered NA due to serial number not installed. Here's a copy of the log entry. Annual inspection. DNA did not accomplish or does not apply by serial number. The engine, there's the information on the engine and the crankshaft serial number. The mechanic missed the serial number on the service bulletin list. He didn't realize that the crankshaft had been replaced at rebuild, so a different serial number was installed. And subsequent mechanics also missed it from 2000 until 2019. Here is the service bulletin that was incorporated from April '98 through March of 2000. Here is the affected engine models and the engine model number and serial number, and they are not on the list. So if you just looked at this list, you would say, oh, it doesn't apply to this aircraft. But if you look further in the service bulletin, it actually lists the crankshafts apart from the engine. And there's the serial number. It was on that list. And then, yeah, in 2011, there were 2 cylinders replaced, and they also thought that the misalignment of the crankshaft during that maintenance caused the fatigue failure, but, and there's the log entry for that. One has to wonder if that crankshaft would have been replaced by the AD. Maybe the proper metal being there might have prevented that from happening. So here's the lessons learned. Engine was rebuilt, crankshaft was replaced. The IA was not aware of the change. Remember our dirty dozen, lack of awareness. He mistakenly thought the AD did not apply. So be sure to thoroughly review the logs and the ADs when looking for applicability. And don't rely on another person's AD review. This went on for 19 years, 19 annual inspections, and nobody caught this. And with that, we will take the last hour. And we're going to do this case study on this oil drain. And there's a lot of lessons learned from these accidents. So on this one, the pilot was conducting the airplane's first flight. Following an annual inspection, about 5 minutes after takeoff, the engine started to run rough and seized. Pilot performed a forced landing during which he sustained serious injuries. Post-accident examination revealed that the engine oil drain valve was damaged when the nose landing gear contacted the valve during gear retraction. This resulted in engine failure due to oil starvation. Further examination revealed that the installed valve did not meet manufacturer specifications. And there was a number of ways that the manufacturer tried to inform owners and maintainers about these engine oil drain valves. And there was an AD issued in 1981 requiring an inspection of the oil drain valve and installing warning placards on the engine mounting frame tubes. There was even a service manual, included a cautionary note. Here's an example of the service manual. Make sure it's a Piper part number 492-172. And you can also see the placards down there. Caution, an unapproved oil drain can cause inadvertent draining when the gear is retracted. Use only a Piper approved part. Here's the AD. Make sure it's a Piper part. Install warning placards. There's a picture of the correct valve on the left and the quick drain on the right. It protrudes a lot farther than the manufacturer's valve. An IA replaced this oil drain during an engine annual inspection. There's a picture of it. It is an approved part. It has a mil spec TSO. Here's his log entry. The oil valve was stuck open during the oil change, so installed a new one and verified clearance with the landing gear. Well, sometimes, you know, air loads are different than on a retraction test. So it was okay when he retracted it on the ground. But in flight, this is what happened. The nose gear contacted the drain and broke it. The oil drained out. The mechanic was not aware of the AD, the service letter, or the manual related to the oil drain valve problem, apparently. Because the AD was never accomplished since 1981. No warning placards were installed. It could have been prevented if, mechanic might have seen the placard. So from 1981 to 2019, IAs conducting engine inspections did not ensure AD compliance. I think that's 38 years. Lessons learned: IA should not rely on another IA's review or AD compliance lists. Review the list yourself. Review AD compliance for yourself. Entries that say NA with no further explanation or justification are reason for concern. You want to know, why is it not applicable? Another lesson is not only to install an approved part, but an appropriate part. And if you're installing anything other than a manufacturer's part, use extra caution. Don't forget the performance rules. Has to be at least equal to the original or properly altered condition. And here's our last AD case study concerning a fuel selector. Aircraft was a Navion. Shortly after takeoff, this happened up in Arkansas. The aircraft lost power at about 300 feet AGL, forced landing in an airport grass area. Pilot and 2 passengers sustained minor injuries, but 1 passenger sustained serious injuries. NTSB probable cause, inadequate inspection of the fuel selector valve, which was degraded. It allowed fuel to leak and resulted in fuel starvation and a loss of engine power. Post-accident examination, they found no fuel in the fuel lines or components forward of the firewall. There was 20 gallons of fuel in the tank. It just didn't get to the engine. Fuel selector valve had blue fuel staining. And they also found that the annual inspection and fuel system AD completed February 7th, 2020 was done just days before the crash. The aircraft only had 18.2 hours since the inspection. Here's a picture of the fuel selector on the accident aircraft. It's in off now, but it was in the main position when the inspector arrived at the scene. Sometimes things are turned off for safety. Here's a picture underneath the fittings, all wet. They're not supposed to be wet. Here's the blue fuel staining. Here's the log entry for the annual inspection. It says complied with ADs, CAD compliance report. Here's the AD compliance report. There's the AD. It says to detect and correct fuel system leaks or improperly operating fuel selector valves. It's recurring AD. And it said complied with per AD. So now let's look at the AD. The gist of the AD is that's the description. Failure could lead to engine power loss within the next 100 hours time in service and follow the Sierra Hotel Aero service bulletin. So that made the service bulletin mandatory. So post-accident investigation of the fuel selector valve, they followed that service bulletin and they did the tests. They noticed that the fittings showed no evidence of being removed recently. There was fuel leaking from the stem and the movement and rotation of the valve was ratchety and all the vacuum tests failed. They failed so bad that they tried another test unit. They thought it was their tester, but it was not their tester, just the valve was leaking. So evidence indicates that the AD on the fuel selector was not performed. This would be an example of falsification of a maintenance record. Somebody sustained serious injuries, maybe affecting them for the rest of their life because this mechanic was not ethical, didn't do what was required. Not only that, he represented that he did complete it. Lessons learned, never falsify a record. Remember, there's no flexibility for that. Make sure you comply with all ADs as per their instructions. And remember how critical ADs are to safety. let's look at the nuts and bolts of ADs. They're issued when an unsafe condition exists in the product and that condition is likely to exist or develop in other products of the same type design. They're legally enforceable rules. And here's the risk assessment matrix. Risk is a combination of severity and likelihood, and the FAA has already determined that an AD is required. The risk is high enough that it requires mitigation. So that's why the AD has been issued. The determination's been made. It has to be done. Responsibilities, registered owner or operator is required to maintain it in accordance with all ADs. But maintenance personnel, we keep going back to the inspection performance rule 4315. You're responsible to determine that all applicable airworthiness requirements are met, and this includes ADs. The log entry must be made when the AD is complied with. And the same information that we looked at earlier for a log entry is required. Some ADs have multiple methods of compliance. We've all seen that. Or some paragraphs may apply to one model aircraft or one serial number range of aircraft and not another. So your log entry should reference the AD number, the revision, and the paragraph complied with as your description of work performed. This is the method of compliance. So, especially if there's different paragraphs that apply to different aircraft, it's important for the owner in developing an AD list. Here's an example where there's multiple items required. I tried to find an example of one. This was the best thing I could find. This AD requires the mechanic to determine if the filter retainer screen is aluminum or steel, determine if the filter frame incorporates a gasket retainer, and then depending on what you find, paragraph B or C is what you do. And I believe there is also a paragraph D to this one, but I didn't list it just to keep things brief. But it's just an example of where you would want to write down what paragraph you complied with. So that's what we're trying to emphasize here. In your log entry, tell what you did, which paragraph you complied with, how you complied with it. Here's an example of a poor log entry. It just says all the ADs were found in compliance. This aircraft actually had a number of recurrent ADs, and the IA did not record compliance or the next due for any ADs. It flew with 5 ADs not complied with. I investigated this particular one. It came in on a hotline complaint. The owner did not keep an AD list after he got a new IA. So from 2011 to 2019, he didn't, the status list wasn't kept up to date. Each AD accomplishment must be recorded at the time of compliance, both one-time and recurring. Here's the same airplane, but the old IA, the previous IA, this is how his log entries looked. And it looks a lot better than the other one. It doesn't just say all ADs complied with, they actually list the ADs. Got the AD, some of them list, I think, the revision number. When you look closer though, look at AD 760712. The actual statement from the AD says within the next 100 hours time in service and each 100 hours thereafter, but his log entry just lists the it actually lists calendar and total time. The AD doesn't give a calendar date, it just lists total time. Here's another one. Here's what the AD says within 12 months and each 12 months thereafter. But his log entry lists both the calendar, the 12-month, or total time. And that's wrong. The AD doesn't state a time and service due, just the calendar date. Make sure you write down what the AD states. Here's another one. Every 100 hours time and service or every 12 months. Now here he got the next due correct. He put the calendar and the time and service, but in this case, the owner would have to track whatever comes first, and it would be helpful to include this on your AD list. Here's a couple good AD log entries. It's got all the elements that are required. It's got the revision or effective date, which is the same thing. Shows the paragraph that was complied with. No recurring action on that one. And on the one on the right, it says next inspection due at 920 hours. So it's all spelled out. On the left is the one time, and on the right is a recurring AD log entry. So what if your product changes? The AD still applies even if the product has been changed by a modification, altering, or repairing. And if the change affects your ability to accomplish the actions required by the AD, maybe it's an STC or a 337, a major alteration, you still have to comply with the AD somehow. So you would request an alternate method of compliance. Contact your FSDO maintenance inspector. And you can also contact the name at the bottom of the AD. They always list the contact information for an alternate method of compliance. Usually ADs have to be complied with before a ferry permit will be issued, but each AD has its own limitations. Here's an example. Here's an excerpt from two different ADs. One of them allows a special flight permit, a ferry permit, and one does not. Sometimes an AD incorporates a service document. And if the service document is modified by the AD takes precedence. Here's an example of a difference between an AD and the service bulletin. The AD prohibits ferry permits, whereas the service bulletin that was incorporated by reference allowed a ferry permit. AD list 91-417 says that the owner shall keep a current status of ADs. Doesn't mean he has to have a list, but he has to have those items: method of compliance, the AD number and revision date, date it was complied with, and the time and date of the next due. Well, the only real logical way to do this is to have a list. The logbook alone will be very difficult to use to determine the AD status of the aircraft. If you have to look through page after page of the logbooks to verify this, it's very tedious. Here's an example of a AD status list. That actually says amendment number. It really should be revision date because that's what the regulation says. And or if it says effective date, that's the same thing as the revision date. The red arrows here are the mandatory items. Method used to comply with the AD. Boy, they don't give you much room there. It's kind of hard to write down what you did. I guess maybe you could put a paragraph number in there. Next, compliance due date, hours or other. Compliance due date. This is when you did it. Date of compliance, the airframe total time in service at compliance. And whether it's a one-time or a recurring AD, then the authorized signature, certificate type, and number. That would be signed, and that information would be put in block there where the blue arrow is, if this was being used as the record of accomplishment as well as tracking the ADs. If that's the case, then this becomes part of the official required records. You could just put in that block, see logbook, dated, whatever. And then the logbook itself would be the actual record of the accomplishment of the AD. Different ways to do it. Here's a computer generated list. There's the AD number and revision date. That's good. The date and hour at compliance shows that it was method of compliance by visual inspection. It lists the paragraph number. There it is, recurring, yes, and the next due. Here's an older logbook entry. Notice the revision dates are all missing, so it doesn't meet the regulatory requirement. And sloppy writers, please make readable entries. These are so important. We have to know whether they were done, the method of compliance, the next due. If we can't read your writing, it's not safe. PCW means previously complied with. See logbook. It'd be nice if they put the date there, so then you could look in the logbook and know right exactly when it was complied with. You could look at the log entry. Here's some obvious acronyms or abbreviations that are used oftentimes. Most of us are pretty familiar with these abbreviations. If an AD is not applicable, here's one. It says it's NA by mod. What does mod mean? Model, modification. Be clear on why it's NA. Use 2 spaces if necessary. I think sometimes the lack of space on these forms causes people to really abbreviate, and you don't get the detail you need. An example of a good entry would be NA because model number XYZ, serial number 123 was found to be installed. Tell why it's not applicable. And if you want to get free AD notes, we no longer mail them, but you can sign up. Most all those websites and locations I showed you have a sign up for subscribing, and then you'll get email notifications. You usually just click and give them your email. Searching for ADs. Yeah, the owner's responsible, but as you know, you have to do an AD search when you're doing an inspection. Make sure you search both the airframe, the engine, the propeller, and the appliances. Don't forget the appliances. And don't forget to look at the bi-weekly listings and the emergency listings. Do you know what appliances are installed? The equipment list is really important for this. If you don't have a good equipment list, then you have to visually look and see what appliances are installed so you know what appliances to search for when you do your AD search. Go to FAA.gov. We looked at this before. I believe this is under regulations. There's the airworthiness directives link. Takes you to this page. The DRS, Dynamic Regulatory System, is our new database for everything. You can also go to FAAsafety.gov, and at the bottom of our page, there's the link. It all takes you to the same place. You can search by product, aircraft, appliance, engine, and propeller. Make sure you look at emergency ADs, new ADs, AD bi-weekly listings. There again is the definition for appliance we looked at earlier. Just make sure you don't forget the appliances. So some pitfalls with ADs: lack of a good AD status list, poor AD log entries, lack of a good equipment list that doesn't show all the appliances that are installed, poor AD search techniques. We saw some of this in the accident reviews. Missing an AD during an inspection. Look at the accidents we looked at. I think one was missed for 38 years by, I don't know if it was 38 different IAs, but a lot of missed ADs. And relying on other people's ADs reviews that they've done. Sometimes one mistake is made years and years ago, and it says AD is not applicable, and nobody ever catches it. They just take their word for it. Oh, it's not applicable because this other inspector wrote not applicable. Verify it for yourself. And we saw that it can result in a violation, an unsafe condition, or an accident, or added expenses for the owner. On the one I was investigating, they couldn't show that these ADs were complied with in the engine, and that engine had to be taken apart to verify whether the AD was complied with or not. I hope we've met our objectives on ADs. We understand the responsibilities, the performance of them, and the record keeping. Understanding the importance of installing only approved parts and the correct part. Remember the drain, the oil drain. It was a good part, but it wasn't the appropriate part for that airplane. Increased awareness of AD pitfalls to avoid, and that will now prevent accidents related to AD compliance. Well, let's look at the inspection requirements. Inspection programs. Owners and operators are required by 91-405 to have the aircraft inspected under 91 subpart E and have defects repaired between inspections. So let's look at the inspection requirements. These are the different types of inspections: annual, 100-hour, progressive, or an approved aircraft inspection program, commonly called AAIP, or a continuous airworthiness maintenance program, a CAMP. Based on the size and type of aircraft, the annual and 100-hour inspections are required or allowed for small airplanes, turbine single engine airplanes, turbine rotorcraft aircraft. They can also select an inspection program under 91409F. The standard for inspections, as we talked about earlier, Part 43, Appendix D, shows us the scope in detail. We must use a checklist. Doesn't say what kind of checklist, but some kind of a checklist. And then we looked at those performance rules for inspections. Those are the standards or the quality that we have to achieve. We looked at who performs inspections when we looked at the privileges and limitations. 100-hour can be done by an A&P, annual by an IA. The 100-hour requirement, it's same as an annual, Part 43, Appendix D, but it's required when carrying any person for hire or flight instruction. They do allow you to exceed that by no more than 10 hours to reach a facility. AAIP is done in accordance with the approved program or manual. And a camp, which is for Part 121 or 13510 or more aircraft, is an all-inclusive program. A camp includes the organization, the manual contents, maintenance training, mechanical interruption reporting, service difficulty reporting, additional maintenance requirements, contract maintenance, required inspections. We call those RII, and a CAS system, a continuing analysis and surveillance system, and also requires a maintenance log entry, commonly referred to as an airworthiness release after any maintenance, and so on and so forth. And next on our agenda is inoperative equipment. As a mechanical repairman, you might be asked to handle a situation where there is inoperative equipment. And the next few slides, we're going to talk about the responsibilities related to inoperative equipment. Here's the basics. It's governed by 91213D. If the owner has an MEL and a letter of authorization, they have to use it. If there is no MEL required to be used, the equipment may be inoperative if it meets that criteria that's listed right there. If it's not listed as required in the equipment list, remember those equipment lists we looked at? It says R beside it, then it has to be operating. If it's not listed as required by 91205, that's a VFR day requirements. Or if it's not required in the airspace, or if it's not listed as required by an AD, then it can be inoperative. It can be deactivated and placarded or removed and placarded. And it must be repaired or replaced or removed or inspected at the next required inspection. Those are the basics. If there's no MEL, deactivation, removal, and placarding. Just placard it inoperative. Or you can remove it from the aircraft and the cockpit control can be placarded. If you remove something, make sure you update the weight and balance. And don't forget the log entry. Can it be inoperative forever? One of these four things must be done at the next required inspection. Remember? Repaired, replaced, removed, or inspected at the next and every required inspection thereafter. And those inspections have to be recorded. Here's an example of how you would record that inspection. Inspected Navcom number 2, deactivated under 91.213D. It is still in condition for safe operation. I'm a good A and P. And there's the signature. Can it be removed permanently? I guess we need to answer that question. Yes, it can be. It can be removed permanently because 213D says that equipment removed under 213D, if it meets all that criteria, it is in a properly altered condition. So it can be. Now, let's say you're using an MEL for inoperative equipment. Let's say they do have an MEL and a letter of authorization. And they'll also have op specs. Be sure to follow the air carrier's manuals. If there's a maintenance procedure, the M or O symbol, the M is a maintenance procedure. Make sure you make a maintenance entry for the M procedure when you accomplish it. Repair categories are applicable to Part 121 and 135 aircraft. Repair categories A, B, C, and D. They do not apply to Part 91 operators. But if the proviso in the MEL says like must repair within 3 flight days or something to that effect, then they do have to comply with the proviso. They don't have to comply with the repair category, but if it states in the proviso that it's going to be repaired within a certain period of time, they do have to comply with the proviso. Otherwise, a Part 91 operator using an MEL will just remove, deactivate, and placard the equipment. It's just the same as the 91.213D process. Last thing on our list, we have to cover a little bit about major repairs and alterations, since IAs can approve for return to service major repairs and alterations. So very briefly, I'm going to talk about that before we close for the day. Here is the basic process. IAs can approve for return to service if the work is done in accordance with tech data approved, not accepted, but approved by the administrator. And there's your resources. I would write this down or take a picture of these resources. This is what 43.9-1F is. That's how to fill out the 337 form. 43-210A, that has some really good flow charts and information there on how to obtain approval of data. Gets you headed in the right direction. Probably the main one, though, is this 8300.16A. I highly recommend that if you're going to do a major repair or alteration, you become really familiar with that. Basic process is you'll determine if it's a major or minor repair or alteration. That's governed by Part 43, Appendix A. If it's a major, make sure you use approved data, and then you'll document it per Part 43, Appendix B, which basically is a 337 form. Or a major repair can be documented with a work order. If you determine it's a minor, then you can use accepted data and just make a log entry. If you determine it's a major change to the type design, if the answer is yes, then you must have an amended type certificate or an STC, supplemental type certificate. A field approval is not an option if it's a major change to type design. If it's not a major change to the type design, then you can use the existing approved data, such as STC, even AC 43.13.1A and what was it, 2B, I think. I think those are also considered approved data now for Part 23 aircraft. Or you can seek field approval of your data. You'll submit a package to your FSDO. Then you'll locate, obtain, and use the approved data to do the work, and you'll document it by 337 or log entry as defined in Appendix B of Part 43. So we really covered a lot of information today, spent 4 hours discussing this, and I hope it's been beneficial to you. I know most of it is, probably all of it is just a review for you. But you know, a review is good. That's why they call it a refresher, I guess. So here's what we covered today. Not really going to read off this list, but we covered all this information. Our website is FAAsafety.gov. If you go there, look under the maintenance hangar for mechanics and under the pilots tab for pilots. A lot of good information there. Best way to learn about the AMT Awards program or the Wings program are to do the tutorials on the website. That's the best way to learn about those. If you have any questions about today's presentation, please send me an email, and I will respond. If I don't know the answer, I'll find somebody that does. I'll make sure you get a